This video is for Homework and Mastery 3.4, Section 12.1, and Appendix D in your textbook. The rules of exponents. What we're going to look at today is the rules of exponents, how we can simplify those when we're multiplying, dividing. When we look at exponents, an exponent is a shorthand number that saves writing the multiplication of the same numbers. 3 times 3 times 3 times 3 gives me 3 to the fourth, where 3 is my base and 4 is my exponent. The exponent tells me how many of that number I have. The base is the number that I'm multiplying each time. This is read 3 to the fourth power. A product rule for exponents tells me that to multiply two exponential expressions that have the same base, we keep the base and we add the exponents. For example, looking at x to the a times x to the b. My bases are the same, they're x. So I can add my exponents a plus b and get x to the a plus b. Let's look at some examples like this. If I have c to the fourth times c to the fifth, I want to simplify this into a single number with exponents if at all possible. So since my bases are the same, I can keep my base and add my exponents and do 4 plus 5, which is 9. When I have coefficients and variables mixed together, I multiply the coefficients of each term if the bases are the same for the variables a and a. And then I will add the exponents of the variables. So 3 times 1 is 3, and a to the third times a to the sixth is 3 plus 6, which gives me 3 times a to the ninth. This is my numerical coefficient, the number in front of my variable. On C, I have 4 times w squared times 2 times w to the fifth. My bases for my exponents are the same, so I can multiply those, and I can multiply my coefficients, 4 times 2. So I'll do 4 times 2, and then I'll add the exponents for my variables. 2 plus 5. 4 times 2 is 8. 2 plus 5 is 7, so I get 8 times w to the seventh. Now if we look at this, I want to multiply 5ab times a negative 1/3 a times 9b squared. Since everything is multiplied, I'm going to take and multiply all of my coefficients together and then multiply my variables together. Where I multiply my variables, I combine the variables with the same base, add their exponents, and then keep the other variables separate. So I'm going to first rewrite it using the commutative and associative properties so that I can get all of my coefficients together, all of my a's and all of my b's together. Now I have 5 times negative 1/3 times 9 times a times b squared. I'm going to multiply 5 times negative 1/3 times 9. When I multiply 5 times negative 1/3, that will give me a negative 5/3. When I multiply that by 9, I can cancel out the 9 divided by 3 and leave me with just 3, so I get negative 15. A to the first times a to the first, I add their exponents and get a squared. B to the first times b squared gives me b to the third. So I've multiplied all of my coefficients, I've combined my a's, and I've combined my b's. When we were just looking at the multiplication rule, we said if they were multiplied, we added their exponents. The quotient rule says we use this form if the larger exponent is in the numerator, and we subtract the exponents. So we're going to take the a minus the b. So here my bases are the same, they're both 3, and so I'm going to say 6 minus 2, which will give me 3 to the 4th. Notice my base does not change. Here my bases are the same, they're both y, so I'm going to do 7 minus 4, and I get y to the 3rd. This is if my largest exponent is in the numerator. Now then, if my largest exponent is in the denominator, I'm going to say b minus a, take my largest number minus my smallest number, but my answer will go in the denominator. I always put my solution to those variables where I'm subtracting my exponents like this in the numerator or denominator where my largest exponent started out to be. So here my 3 squared divided by 3 to the 9th, my bases are the same, but notice my largest exponent is in the denominator. So I'm going to leave everything in my denominator and have 1 divided by 3, 9 minus 2. The 9 minus 2 becomes 7, and I get 1 over 3 to the 7th. I have the same thing with negative z to the 6th divided by z to the 11th. My largest exponent is in the denominator, so I'm going to leave it 1 over a negative z to the 11 minus 6. 11 minus 6 is going to be 5. So my entire equation, my entire fraction is negative, and I'll get 1 over z to the 5th. Here's some where we've got several different things going on. We've got division problems where we've got some variables with the largest exponent in the numerator and some variables with the largest exponent in the denominator. So we have to figure out for each variable where should my exponent become. Well, if you look at the coefficients, I just have a 1 over 5. So I'm going to have still a 1 over 5. X to the 3rd divided by x. My largest exponent for my x's is in the numerator, and that's going to be 3 minus 1, which will be 2. My largest exponent for my y's is in the denominator. 6 minus 2 will be 4. So I get x squared divided by 5, y to the 4th. I do the same thing with negative 3x squared y to the 5th divided by 12 x to the 6th y to the 8th. I look and I say, okay, how can I separate my coefficients? Negative 3/12, and I can divide both of those by 3. So I'll get 1 over 4. Look at my x's. Where is my largest exponent? It's actually in the denominator. So 6 minus 2 will be 4. So x to the 4th. And then my largest exponent for my y's is also in the denominator. So I'm going to do y to the 8 minus 5, which is y to the 3rd. I've canceled everything out in the numerator, and so I just have negative 1 divided by 4 x to the 4th y to the 3rd. Another part of the quotient rule is if the exponents are the same and they cancel out. Anything raised to the 0 power becomes 1, and so we have to look at that. If everything cancels out, our solution will be 1. Here I have 15 to the 12th divided by 15 to the 12th. Well, 12 minus 12 is 0, so 15 to the 0 will be 1. On part B, I have a to the 3rd, b to the 0, divided by a squared. Well, b to the 0, that just becomes 1. And so I'm left with a to the 3rd divided by a squared, and I do 3 minus 2, which will be a. I now want to look at if I have a power raised to a power. I always keep the base just like I have been in everything else, and I want to multiply my exponents. So in this case I'm going to have x to the 8th power raised to the b power is equal to x to the ab. So for these two examples, I have x to the 5th all raised to the 3rd power. So I'm going to multiply 5 times 3, which will give me x to the 15th. I have y to the 3rd raised to the 3rd. I'll multiply the 3's and I'll get y to the 9th. So anytime that you have a power raised to a power, we're going to multiply the exponents. Also, if you have items that are multiplied and the whole thing is raised to a power, we can distribute the power. We can say that x is raised to the a and the y is raised to the a. So anytime that we have something inside parentheses raised to a power and there's not addition subtraction, you can distribute your exponent. So for example, 2c all raised to the 3rd power. That's the same thing as saying 2 to the 3rd times c to the 3rd. 2 to the 3rd becomes 8, c to the 3rd. Then I have negative 5xy squared. So I'll square everything. Negative 5 squared, x squared, y squared. Negative 5 squared is negative 5 times negative 5, which gives me a positive 25. And I get 25 x squared, y squared. Here I have 4x to the 3rd, y to the 2nd, all raised to the 3rd power. So I'm going to distribute this 3 in here, and I'm going to get 4 to the 3rd times x to the 9th, because 3 times 3 is 9, y to the 6th, because 2 times 3 is 6. 4 to the 3rd power, 4 times 4 is 16, times 4 is 64. So I get 64 x to the 9th, y to the 6th. The same thing happens if it's division and everything is raised to a power. The numerator gets raised to that power and the denominator gets raised to that power. And then we can distribute the power as needed. For example, if I have x divided by y raised to the 4th power, I can distribute my 4 to the x and to the y, and I get x to the 4th, y to the 4th. If I have 3 times a to the 3rd, b divided by b squared, all raised to the 4th power, I separate it out and distribute my 4 to every power, such as I've done here, 3 to the 4th, a to the 3rd raised to the 4th, b squared raised to the 4th. 3 to the 4th becomes 81. 3 times 3 is 9, times 3 is 27, times 3 again is 81. A to the 3rd times 4 is going to be 12. B squared raised to the 4th, I multiply and get b to the 8th. So I'm distributing anything that is raised to that power. Notice, these are only for multiplication and division. If there's an addition or subtraction sign in there, we have to treat those completely separate. So please be careful if you have a addition or subtraction in there. We will discuss those a little bit later in the class. But for now, your exponents, if it's multiplied, we add, divided, we subtract. If it's raised to a power, we distribute and multiply. If you need any help, let one of us know.